Got it. Okay, so we're going to do 2 more examples for 3.3, and then that's all I got for you. So, and this is one of the wordy ones, but we're in stats, like it's not college algebra, so there always is a lot of words. So, let's say we have this example. This is the 3rd example that we're doing. A physics class has 80 students. Period. Big old class. Okay, so 28 students are physics majors. Comma. It says 31 students are female. Period. So of the physics majors, 15 are female. Period. Okay, so what we're going to do is we're going to find the probability. I'm going to read it all and then we'll write it. Find the probability that a randomly selected student is a female physics major. Okay, so find the probability that a randomly selected student that a randomly selected student is a physics major. I'm sorry, is a female physics major. I was like, what is that? It's my phone. Okay, so I have a class of students. It's a physics class, right? And there's physics majors that are in this class, and it told me that there are physics majors who are female. So this is not mutually exclusive, right? There's an actual overlap where I have females that are majoring in physics, okay? So we can go and I just put not mutually exclusive. It's my own little note to myself because it helps me whenever I look back at my formulas. I mean, I literally just wrote in here that there are some that are both of these events, right? So they're not mutually exclusive. I'm flipping through the 5 right here. So remember, if they're mutually exclusive, you just do this, and then you add the other one. But these aren't, okay? So I need to actually do the probability of one event occurring, add to that the probability of the other event occurring, and then this right here takes out their intersection, so I don't count however many physics female majors there are more than once, okay? So I've got physics majors and I have females. I'm going to do this one, add this one, and then where they overlap, if I don't take out their intersection one time, I'm counting those students more than once. I'm actually counting them twice, like exactly twice. So you have to take them out once. So the probability of female physics major is going to be the probability of the first event occurring, which is the probability of female. You can just do capital F, right? And then I add to that the probability of physics major. I just wrote physics because because that should make sense, okay? Probability that it's a female, probability that they're majoring in physics, and then because there is an overlap in these events, I need to subtract one of the occurrences that they're both, okay? Because I don't want to count them more than once. So the probability open F in physics. This is literally the exact same odd and less than 3. It's just a little bit wordier of a problem. And hopefully like all these different things are making sense, like where it's coming from, but it's the exact same problem. This was rolling a number less than 3. This is rolling odd, and then this is making sure I don't count that overlap of the events more than once, okay? So obviously we're not dealing with as small a numbers as we were with the dice, right? If I look at the probability that the student is female, when I look, oh, sorry. You see where it says 31 students are female? So that's giving me the number of outcomes for this event. The event of the student being female, I look, how many females are there? And it's out of the total number of students, which is how many? 80. So I have 31 over 80, and then I'm going to add to that. Okay, that's just the female. Now I add to that the probability that they're physics majors. How many physics majors are there? There's 28 out of 80 students. So here's where I got that, physics majors. Female. All right, 31 females, 28 physics majors. Okay. Now it says of the physics majors, 15 are female. That's just another way of saying that it satisfied both events, right? It's here and here at the same time. So it says of the, I'm going to need to subtract this. This is the intersection. Of the physics majors, 15 are female. So the probability of being female and physics is going to be the 15 of them out of the 80 students. That's kind of this whole thing right here. This is where I got, that's the intersection. I'm trying to think if I could draw this up real quick. I don't know the whole, that would be 80. It doesn't tell me enough, but there would be a way if we knew a little bit more, we could do the actual Venn diagram. And you could see that there's so many females, there's so many physics majors. This is where they intersect. When we enter this into our calculator, you could, y'all, really, look, I mean, you could just do this. Do you see how the denominator is the same, right? And so you could do 31 plus 28 minus 15, and I get 44 over, keep your denominator. I've got 44 here. I could just go divide by 80. 0.55. And so that's how you do that problem. It's a little bit wordier, but it literally gives you every single piece of information that you need. Okay? Okay, so let's do this last one. This problem's a little, it's actually just, it's really straightforward. It looks like a lot when you write it down. It's not sentences and words in a paragraph. It's just a whole bunch of like probabilities that they've already computed and that they give you. Okay? So, this is the fourth and last example for 3.3. So, this is what they say. They say given the probability of A is equal to 0.43, and the probability of B is equal to 0.29, So they've already kind of computed all this. All they're giving me is just all these probabilities. Okay, comma, the probability of C is 0.16, comma. I got 4 more to give you. Okay, like they're going to give, I'm not even lying, they give you everything. It's understanding the formula, seeing how you need to set it up, and then you're literally just entering all these decimals in your calculator. Okay. The probability of A and B, so that was the multiplication rule, right? Like they've already done it. They've already done the multiplication of this, and what we get for the probability of A and B is equal to 0.11. Probability of A and C (0.02). We need to go ahead and pair together B and C. That is 0.05. And then lastly, the probability of A and B and C. It's equal to 0.01. Right, now it tells me what it wants me to find. And that's what we're going to find. We're going to find the probability of A or B or C. Kind of just recall something so it makes sense. Okay, so this is just going to be multiple events, so it's going to use the same formula, but it's just going to make it longer. So we don't just have 2 events. When we had 2 events, A and B, and we had the word or, we took A, we added B, and then you subtract A and B. We don't have A and B now. We have A, B, C. So what we're going to have to do is you still follow the same type of format. We're going to take event A, add B, add C, and then subtract all of the A and B, B and C, A and C, and then lastly, subtract the biggest, longest one right here. So it's going to be like this, plus this, plus this, minus that, minus that, minus that, and minus that. So we're just going to do all that. Just this plus, 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 minus. Okay. So the way we're going to do that, and I'm going to actually write it down like what we're doing, and then we'll just plug in the numbers. Because it takes a little bit of room, I'm going to start it right here. So not exactly right next to my equal sign. Okay. Because it's an or, thank you. Because it's an or, if we just had this, we've done it all day, not a problem. A plus the probability of B, and then subtract their and. Okay, we're just adding one more. So we take the probability of A, we add to it the probability of B, we're going to add to it the probability of C, and then what we do is we subtract these, the A and B, the A and C, and the B and C. And then the last one, we're actually going to add it to it. And then that's your answer. And like, you can't have a problem on your note card that y'all can have for the test, but like you could have what I'm writing out right here on it. Okay? So A or B or C is A plus B plus C minus this and subtract the A and C, subtract the B and C. And I still ran out of room. Now we need to do this last one right here. that one gets added to it. So add, I'm going to circle that plus sign to show you that it should be written here, but I ran out of paper. This is literally just a formula that you could write on your note card for the test. That makes sense? It's long, but write it. Okay? I feel like I should have to say that again. So probability of A or B or C happening. We start here. What's the probability of A, y'all? 0.43? 0.43. And then add probability of B. So I'm going to do a plus sign. 0.29. If you did the zeros in front, that's fine. Just kind of give them off. And it tells me to add probability of C. Right? Now subtract A and B. Subtract A and C. Do you see how I just like add, subtract, 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 add. And so they even give it to me in the order that I'm using them. Like, it should take like 5 seconds to do this on a test if you saw it, or a homework problem. Okay. Now subtract my A. 1, 2, 3, 4. 1, 2, 3, 4. My A and C, which is 0.02. Subtract 0.05. And then after that, I'm going to add 0.01. Whatever you get, that's your answer. I had to count because I felt like I kind of lost my place there a minute ago. Bless you. 0.43 plus 0.29 plus 0.16 plus 0.11. Oh, I said plus, that's a minus. So subtract that. And subtract 0.02. Here's some tissue, babe. I don't think we have any. Oh, we do. Yay. I forgot who I was telling earlier with all like the sniffling and the coughing. I'm like, y'all all sound like my kids right now. Cameron actually just texted me earlier. I don't know what he said, but that I needed to go and buy all kinds of stuff before I came home. No one's feeling good. Everyone should get 0.71. Okay? That's actually, with all of this information they've literally given me, and then just having this formula written down, I come up with the fact that the probability of A or B or C occurring is 0.71. And y'all, that's it for 3.3.
So the second part, like the second line is what we can write on the card?
Yeah, all of that. You could literally write this. Yeah, I would just write small because I mean, I have a marker. I'm writing a little bit bigger. But yes, if you were to see, I mean, it would basically be the same exact format, right? It'd have to be the same format because the sentences and stuff that would go along with trying to explain all of this would be insane. It's just, it's given. Here's information that's given, and this is how you can compute it. If problems are worth, 4, 5, 6 points each, that's kind of like a gimme because I have this formula written down on my note card and I just kind of follow it, and I remember add, subtract, 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 add. And yeah. Okay, y'all.
So we get to use